Okay, we're going to fill out this note sheet. So you need the note sheet, and you're going to need a periodic table of some kind. You can use the one that's in your planner, or you have that one that's taped to the back cover of your journal, or there is a stack of them in the classroom. So you need a periodic table and your notes that you just took. So we're going to fill in this paper. So I'm going to start over on this side. So these energy levels are called energy levels. Some things that you will read refer to them as orbits. To me, orbits is a bad word in that when you think of orbit, you think of planets orbiting the sun, but in reality, electrons can be any place at any given time in energy levels outside that nucleus. So I call them energy levels. So in this box, you're going to write energy levels. This whole central area is called the nucleus. Let me make this bigger. Nucleus. Okay. The subatomic particles that are on the energy levels outside the nucleus and what we call the electron cloud, those are electrons. And one of the problems with the diagram is that the electrons are the same size as the protons and neutrons, but in reality we know that the electrons are 1800ths the size of a proton or neutron. So they would actually have that mass of 0. So this is a problem with this diagram. So then we're going to go into the nucleus. The nucleus is made up of protons and neutrons. Your protons in a stable, or shall we say an atom that has no charge, is going to be the same as your electrons, because your positive charges will equal your negative charges. So I have 3 protons, so I have 1, 2, 3. I have 3 electrons, so I should have 3 protons. So protons. And then the other subatomic particle would be your neutrons. Okay, so that should get that filled in. The atom shell, see, it calls it shell number. And so number 1, this would be number 1, and this would be number 2. Remember, we're going to refer to them as energy levels. The first energy level can only hold 2 electrons, and that's it. That's all that can fit there. The second energy level can hold up to 8, so a maximum of 8 electrons. The third energy level can hold a maximum of 18. However, for the majority of the ones, or probably for all of the atom models that we're going to draw in class, we're only going to need 8. But it can actually hold up to 18 once you get past atom number 18. Once you get past argon, then you will have more electrons in that third energy level. Okay, so looking here, the number 3 here at the top is called your atomic number. And like I said, all of this is from your notes, which is the number of protons, which is equal to your number of electrons. Remember, all the atoms on the periodic table, every atom on the periodic table is neutral. It has no charge. So it's going to have the same number of protons as it does electrons. However, when you're identifying an atom, so if I give you a diagram, or you have something that reads out and it tells you how many protons, electrons, and neutrons this particular atom has, you always look at the number of protons, because the number of protons is your atomic number, and that's how you will always correctly identify which atom you have. Okay? The atomic symbol is going to be 1 or 2 letters. Okay? The atomic symbol is going to be that chemical name, and it's either 1 or 2 letters. If the first letter is always capital, the second letter is always lowercase, you have to be very careful with that and make these very neat so it's very legible that the first letter is capital and the second letter is lowercase. Or it could be things like boron, carbon, nitrogen, oxygen, which is just one letter, okay? And it is clearly a capital letter. The bottom number is the atomic mass. Now, sometimes the atomic mass will be at the top, sometimes the atomic mass will be at the bottom. I've seen them where both are at the top. Just always know the atomic number is the smaller of the two numbers. So the atomic mass, or sometimes I've seen it referred to as just the mass number. And for ours, it is at the bottom. And you'll notice this says 7. If you look at the periodic table, lithium is 6.941, and so it is just rounded to a whole number of 7. Each of these atoms occur in more than one form. So for example, hydrogen, there are actually 3 forms of hydrogen. They all have one proton, they all have one electron, but they have different numbers of neutrons. Okay, so that's why it is an average, and every element on every square represents the most stable form of that atom on the periodic table. Okay, so the atomic mass is the total number of protons and neutrons. So that's what makes up the atomic mass. So here, to find the number of neutrons in an atom, you need to subtract the atomic number from the atomic mass. So atomic mass minus atomic number equals your number of neutrons. And in order to do that, you will need to round to a whole number, that mass to a whole number. So here we have this little chart. So our clue is it is a negative charge, so a -1 charge. So the subatomic particles you have electrons, protons, and neutrons. Electrons have a negative charge, so they are negative, okay? So down here you're going to put electrons. They have a negative charge. Their mass, remember I had said previously that electrons have a mass 1/1800th the size of a proton or a neutron. So their mass is 0 AMU, atomic mass unit. They are located in the energy levels. And this would be the electron cloud. Okay, and so that is outside the nucleus, okay? So they're outside the nucleus on the energy levels, or in the most modern form of the atom is called the electron cloud model. Okay, so this one has a charge of 0. So we know electrons are negative, then we have protons and neutrons. Protons have a positive charge, positively positive protons. Electrons are negative and neutrons are neutral. Neutrons have no charge, they are neutral. So no charge, so we know this is a neutron. They have a charge of 0, they have a mass of 1 AMU, and they are located inside the nucleus. Okay, so that leaves us the other subatomic particle inside the nucleus, and that's going to be our proton. So proton, they have a charge of +1. They are positive charge, and they have a mass of 1 AMU, and they are located in the nucleus. Okay, so that should have that part filled in. Okay, we're going to go over one more thing. I want you to take your paper, and you're going to fold it so you can still read your title. Okay, and we're going to practice finding protons, electrons, and neutrons. We're just going to do a few little sample problems. So you're going to need your periodic table. Okay, so let's look at beryllium. So here's beryllium. So I'm going to put Be. All right, beryllium. It has an atomic number of 4. And it has a mass of 9.012. So we're going to round this, and we're going to round it to 9. So I'm going to put it like that. All right, we're going to identify how many protons, electrons, and neutrons it has. So remember, protons are positive, electrons are negative, and neutrons are neutral. So, if you remember from your paper, the number at the top is your atomic number. Okay, so my atomic number is 4. So I have 4 protons. If I have 4 positive charges, I have to have 4 negative charges to balance it out. So I have 4 electrons. And in order to find neutrons, I have to subtract these two numbers. So 9 minus 4 equals 5. So I have 5 neutrons. So now I have identified how many different subatomic particles I have for beryllium. Okay, let's try nitrogen. So find nitrogen. So we're going to put N. We have atomic number of 7. It is 14.007, so we're going to round it to 14. We're going to put protons, electrons, neutrons. Atomic numbers are number of protons. We have 7 protons. If we have 7 positives, we have to have 7 negative charges, so we have 7 electrons. We have 14 as our atomic mass, so we're going to take 14 minus 7 gives us 7. So we have 7 neutrons. Okay, so remember, this is our atomic mass. This is our atomic number. You subtract those two, and that's your number of neutrons. So atomic mass minus atomic number gives you your number of neutrons. Right, let's do one more. I think you've got this. This is not too bad. Okay, so let's look at potassium. Potassium right here, it's atomic number 19. So I'm going to put a K. We have atomic number 19. Our mass is 39.098, so that rounds to 39. We have protons, electrons, and neutrons. Okay, so if my atomic number is 19, I have 19 protons. I have 19 electrons because they cancel each other out. To find our neutrons, we take our atomic mass of 39. We subtract off our atomic number, okay, and that should give us 20. So we have 20 neutrons, which my 2's look like Z's. 20. Round it out. Okay, so hopefully that will show you how to find your protons, electrons, and neutrons. Okay, so when you tape this in your journal, you'll tape along that, and that way you can still open it up and read the notes on the inside, and you have your little notes on the outside.